Good morning, everybody. Good morning, everybody. Let's start today's lecture. Yesterday, we talked about classes a lot, why we are using classes, what is the meaning of a class in terms of object-oriented programming languages concepts, and how we use it. So our discussion will continue like that. We will keep talking about classes, why they are important for object-oriented programming. Also, we will keep talking about how we do class-related processing in C++. One important component of classes are constructors. Constructors are member functions, but they are special member functions. They are used for initializing a object, class object, and there are many other functions of constructors too. Remember, I asked the question yesterday. I said that let's say we have a day of year. We have two day of year objects, day 1 and day 2. When I say d1 dot input, okay, the user enters some values from the keyboard, and when I say d1 dot output, let's say the user entered the February 15th, okay, when the d1 dot output would print these two values, February 15th, on the screen, right? That's what we said last time. But how about this? I also asked this question too. How about this one, d1 dot output? What was the answer? If I do that, it will print something on the screen. So what would it print? It would print garbage, right? And that garbage will most likely be 0, 0, okay? But remember, our output function, it doesn't accept 0 as a valid month number. So it's going to be the error or some kind of a stupid thing. We don't like these kind of things happening in object-oriented programming languages. If you made an object, that object should be always valid, okay? You don't get to say, I did not initialize it. You don't get to say that, well, it is not still usable. I am preparing it, etc. So as soon as the object is created, as soon as the object is in memory, we like objects to be valid all the time, no exceptions. Okay, constructors are good for this because constructor, as I said before, is a special function that is called automatically as soon as your object is created. When you execute this line, the constructor function for object d1 and d2 will be called automatically. Okay, you don't call constructors, they will be called automatically. Since these constructor functions are called automatically when the object is built, okay, it is up to you how you initialize your object. You might say that all of my day of year objects will be initialized to January 1st. Okay, it is your decision because it's a function and you are writing that function. So that's basically the definition of constructor. And in all object-oriented programming languages, since we have classes, with the classes you have to have constructors. You will have to have some kind of a constructor idea in all of the programming object-oriented programming languages. So let's look at the constructors. Okay, it is used for initialization of objects. You use constructors to initialize some or all member variables. Okay, if it doesn't matter, then you don't initialize some of the member data, but usually we initialize all of them. And the main job of constructor is to initialize the data, but you might want to do some other stuff too, and we are going to see what might that be, because it's a regular function actually, and you can do anything you like. Okay, it's a very useful tool for object-oriented programming, and a kind of special member function. And why do we say special? Because it is called automatically, and its name is kind of different. Okay, so without actually going that much, let me show you one example directly from the book. Okay, remember our day of year class? I changed day of year class. Let's look at these lines: input, output, and get month number. These are our three functions that we used to know before, or four of them. Okay, here it is. Okay, so I have two getters, get month number and get day, and these are getters, actually the accessors. Another accessor is output, a mutator is input. Okay, and there were a few other functions, but for the sake of simplicity, we got rid of them. And I have these one, two, three functions. Look at the names of these functions. They are all the same. Day of year, day of year, day of year. And it is the same name as the class. Okay. These are constructors. These are constructors. Okay. Constructors have to have the same name as the class. You may not have a constructor with a different name. Whatever your class name is, your constructor name has to be the same. And it looks like I have a constructor that doesn't take a parameter, a constructor that takes a single month value. It looks like it is going to initialize to that month of the first of that month, and a constructor that takes both month value and day value, both of them. Okay, and in our private section, I have my month, day, and it looks like there is a test date. So somebody has written a helper function to test if the date is valid or not. A question? If there's a question?
Is it have to be public or can be a default or private?
Most often, 98% of the time, constructors have to be public, because if you don't make your constructors public, nobody can create an object of your class. What did I say? Okay, let me show you this example. I have three day of year, line 31. I have three objects created, day of year objects, date 1, date 2, and date 3. This date 3 is using the third constructor that doesn't take a parameter. This one takes the second constructor, and this one uses the first constructor. Okay? To be able to write line 31, I need all of my constructors to be public. If they are not public, then I will get a compiler error. The compiler will tell me that the constructor of this class is not public. You may not use it. It is like trying to call this test date from outside the class. Okay? So, but there might be some cases that you don't want your classes to have objects. Then in that case, I mean, that's a weird situation, but in that case, you make your constructors private. But I don't think that in our book we have a single example that makes this private. Okay, so line 31, we are seeing some new stuff. We have never seen an object definition like this: date 1, 2, 21, date 2, 5, and date 3. We did this before. Day of year, day 3, we did this before without any parameters, but now we have constructors that take parameters. And I call the function output on each of them, and they will be printed out. Date 1 output will print February 21st. Date 2 output will print May 1st, and day 3 output will print January 1st. And if you like, at line 37, this is a very, very rare case. Okay, don't use this. If you like, you may make an object like this. This is just an object. You are making an object with the parameters 10 and 31. Okay, that becomes an anonymous object without a name, and I assign that temporary object to date 1. This is possible to make assignment. This is possible to make changes to your date 1. So you are not directly changing your date 1 data members. You are making a new object and you are assigning it, which is kind of not good, because if you like to change the values of your objects, then maybe you should have a setter in your function here. Okay, let me go to book and let's okay, here is our class definition again. Very simple. Input and output is there, month and day is there, right? We talked about this, and it looks like we have a single constructor. No overloading here. Okay, the name is the same as the class. Day of here is the same as the class. And the other thing is, constructors, they don't return anything. Okay, they cannot return anything. There is no return type for the constructor. Its name has to be the same as the class, and they don't return anything. Okay, these are the two special things. Compiler recognizes constructors that way. Okay, has no return type, not even void. Okay, and constructors are in public section for now. Okay, if private could never declare objects, we already had a question about this. When the objects are created, I like to create two objects. One is going to be called date 1, the other one is going to be called date 2. Okay, and in this case, depending on what the constructor does, it is most likely is going to assign 7 to month and 4 to the day, and 5 and 5. Month, day. Of course, I mean, the fact that you are calling your constructor this way doesn't mean that the initialization will be done automatically. Okay, it is up to you again, because you are writing the constructor yourself. Okay, so we are gonna see some examples later. You might think that it is okay to call a constructor like this. No, it is not. Constructors are not regular functions. You cannot call constructors this way. Constructors are called exactly once in the lifetime of objects. Okay? When the object is created, the constructor is called automatically by the compiler. You may not call the constructor again on the same object using this kind of annotation. You might say that we did this, right? We did this. Date 1 gets the value of day of year and 1, right? We made a call like that. This is not calling of constructor for an existing object. This is calling of a constructor for a new object. This makes a new anonymous object with no name, and I make an assignment of that object to date 1. This is date 1. Okay, good. So cannot call constructor like other member functions. It is not like regular output or input. Okay, so the constructor code is like this. What do you say? Remember how we declared our meta functions and how we implemented them? To implement a function, you say the name of the class, and inside that class I am implementing this function. Since name of the constructor has to be the same as the name of the class, I write it this way, but no return type, because constructors do not return any return. any return value. And in this case, I am taking two integers by value. Okay. Somebody has their mic on and it is making a noise. Could you guys turn off your microphones? Where is that mic is coming? Oh, okay. Maybe it is my computer. Okay. So what I do is I assign this value to my month data member, and I assign this value, okay, to my day data member. I use it for initialization. This is a regular function in terms of what you write in it. You can do other things too, like maybe if you like to do it, you may just put an if statement in there. If something something something, then I don't accept this. So for example, a check. Okay, for example, a check. A month cannot be less than 1, month cannot be greater than 12, etc. Okay, any questions so far? You're so quiet today. Okay, I will continue. Maybe you will have later questions. Okay. An alternative definition is this. If you're going to initialize something with a constructor, C++ tells you that if you are going to initialize it, you may initialize it this way. Okay. Right after the right parentheses, okay, you put a column and you say that my month will be month value, my day will be day value. Okay. And this line here, this line with a frame of red here, is called initialization section. To initialize your member variables, you would use this notation in C++. This is valid only for the constructors. You cannot use this notation for any other function other than the constructor. Okay, this is called initialization section, and body is left empty if you like. I mean, if you don't have anything to do other than the initialization, then body is empty, and this is the preferable definition. This is better because you are telling the constructor that I am doing this just for initialization. This one, again, this one initializes, but the compiler doesn't know that you are doing it for initialization. Okay. At the end, it turns out that you initialize your stuff. But here, you are telling the compiler that this line is for initialization. Compiler knows that. And these are my initial values. And that's a good thing for a number of purposes. It is readable first. And it is something that the compiler can take advantage of to make things faster, to produce better code, faster code, more efficient code. Okay, so we like this initialization better than this one. This is okay, but this is better. Good. And as I said before, we use constructor to initialize data in our objects, but and if you use this initialization notation to initialize your objects, what are you gonna do inside the body of your constructor? It doesn't have to be the empty. Okay, as I said before, we can validate the data. That's another thing with the object-oriented programming languages. Okay, I don't trust my customer. If the customer says let me use a day of year D1 month 27 day 10 minus 10. If the customer says this, the user of the class says this, okay, This one will make the initialization month to 27, day 2 minus 10. I don't like this. Why? Because these are garbage values. Okay? These are garbage values. I don't want my users to be able to give me this kind of stuff. So what am I gonna do? I will write some extra code inside here to make sure that no such stupid things are happening. Okay, so that's called validation of the data. That's called the validation of the data. And with the validation of the data, you ensure that only appropriate data is assigned to your private member variables. Okay, and it's a powerful object-oriented programming principle. You never let your objects to be invalid in any time in their lifetime, from the birth to the end. Okay, from to birth to the death, they should always have valid values in them. Anil the question: can we call setter in a constructor for validation? Of course you can. Yes. Constructors are special functions, but they are functions at the end. And you may call any functions you like inside the constructors. That will include the private functions or public functions or any global functions. Okay? So that's a good idea to call the setter inside a constructor. That's a good idea to call the setter inside a constructor so that we know that the setters have this check, validity check feature. Okay. Like any other function, constructors can be overloaded, no problem. Constructors can be overloaded, no problem. And you may have more than one constructor. And of course, each one should have a different signature. One of them will take one parameter, two parameters, three, or types of parameters might differ. Okay. And this is the code that I just showed you a few minutes ago. Let me go to, instead of this one, or maybe yeah, let's do this. Yeah, okay. So day of year, it has three constructors. I have input and output, and get month number is there, and get day is there. I have month and day, and there is a private test date function. And I have already shown you the driver code, the main function. It created three objects, and I called output one of them. Okay, and I made this anonymous object again. I made this assignment. As I said before, let me stress this out. I don't like this line at all. This is a bad line. We don't use this kind of notation in our regular C++ code, but this is just an example to show how I can use a constructor. Okay, and then I print out this values of this date one. Our first constructor implementation. I get these values as parameters, and using the initialization section, I make this assignment. And inside the constructor, it is not empty. I call this, see this private function here? I call this private function to test the date, if the date is valid or not. Okay, this is our first constructor implementation. Notice that there is no return type. Okay, Atakan has a question. In the initialized version, due to data assigning is before the brackets, how can we check validation? That's a very good question, Atakan. He says that if this is -5, if this is -10, initialization will work automatically. But in that case, after initializations work, okay, initializations happen before this function starts running. Initializations will happen before. When the function starts running, it will see that the initialized values will be invalid. Okay. So there is no easy way. There are some ways of doing it, but there is no easy way to make a validation at this initialization section. Of course, there are ways, but maybe you may figure that out. But usually we do the assignment first, then we do the checking here in the test date. Okay? Good. Let's look at the other constructors. Okay? The second constructor takes a single parameter, and it sends this data to month initialization, and for the day we just use a value of 1. Okay, so it initializes the object to the first day of some month. Then we call the test date. And the last one is the constructor with no parameter. It says that my month will be 1 and day will be 1 because I know that these are both valid. I don't call test date. Okay? Good. And this is our test date function. It says that, look at the simplicity of the function header. It doesn't take any parameters. It just says that I am working on an object, and month should not be less than 1. Month should not be less than 12. Day should be between this range. And anything outside of these two ranges, I will print this out and I will exit. Okay. Nobody has asked this question. Usually I get this question. How come, what is exit? Exit is a global function, right? And it comes from C. Since C++ is a superset of C, whenever I need it, I can use these global functions. We don't like to write global functions, but we use global functions a lot. Okay? So this is how you call a global function. To call a global function, I don't need an object. Okay? But to call for example, to call a output function, I need an object, right? You may not call the output function without the object. But how about this case? Test date is a member function. It might be private, but it's a member function. How come I can call this test date without an object? It is called like a regular global function, right? Jacob says that test date is in the class, and somebody, because it's a member function of day of year. What else? Test date has to work on some kind of an object, right? Test date has to work on some kind of an object. When I say day of year, day 3, okay, day of year. When I say day of year, date 1, this is the object. Okay, this constructor is working on this object. And when I make a function call here, this function works on this object. And it is okay to write something like this after test date, if you like, output. I can do this too, because I am already working on an object. Somebody told me this. Okay, somebody told me this. Okay, good. And we are gonna see examples of this in many times. Okay, so this is test date, and let me go to the original code and let's check the. Okay, this is the original code. Test date is here. Test date is there. Test date. Get month. Now this is our getter, and input. See, with the input, instead of writing this code, this would have been much better code. Okay, I got it, and I am calling test date. It's the same thing. If somebody calls input on an object, okay, d1.input, I get the month and day from the user, okay, and I call test date instead of doing this if checks, okay. I don't want to do that. Instead, I like to do this. This is much better because we don't like code repetition. What is bad with code repetition? Why we don't like? Can anybody tell me why we don't like code repetition? Copy paste code and make modification. We don't like it. Muhammad also says that readability is bad. Yeah, that's true. And Fatih says that it causes spaghetti. Well, spaghetti usually is caused by the gotos. Okay, with this spaghetti, it is. I mean, remember when you use gotos, all the arrows are crossing each other. Yeah, it's a bad coding style. Okay, it is difficult to. I think I think my connection was. Let me try to. Let me just a minute. Sorry. I should. Okay, good. I should work on it. So it's a bad thing because it is not readable. I mean, if I am putting this code in here, whoever reads it will think that this is somehow different than this, right? This is somehow, maybe the values are different. Maybe I am testing it differently. Okay, that's one thing. The other thing is this. Let's say I have realized that these should be like this. Okay, I made a mistake and I am fixing it. When I fix this value here, I have to go back and I fix the value here too. And I have to remember all the places where I fix that value or where I use that value. But instead of doing this, just erase these three lines and call that state. If I realize that there is a mistake, I just come here and I fix it in here, and that fixes all the problems. Okay, so copy paste makes any errors worse because you are spreading your errors all over. Okay, good. And we fixed that problem. Input, output is already there, and that's the whole code. Okay, any questions? Okay, Atakan, copying and pasting is not a violation of object-oriented programming principles. It's a violation of many programming principles. I mean, in C, although you are not doing any object-oriented programming, okay, you shouldn't copy and paste and modify. Okay, you should copy and paste and modify. That doesn't mean that you should never copy and paste. Okay, programming is done iteratively. You write your first iteration of your code. Okay, once you get your code working, you go back and you fix these kind of problems like copy paste stuff. And if your functions are longer than maybe 30 lines, make them smaller than 30 lines. If you realize that some of your functions names are bad, you fix them and you give them better names. Okay, so second iteration and third iteration, etc. So we use copying and pasting and modification, but at the end of your second or third iteration, you should get rid of these kind of copy pasted code. Good. Let me continue then if there are no questions. Okay. The constructor with no arguments is kind of weird. See, look at this definition. We make a declaration of object date1 like this, but not like that. Okay? You might think that, well, how about this case? Day of year D2, 5 and 7. If I use parentheses in this like that, I mean this like calling a constructor, why don't I call the constructor like this? No, you don't do it this way. This is not an option, okay? You cannot. Because if you do it this way, compiler will be confused between an object declaration and a function declaration that doesn't take any parameters and returns a day of year object. This is it looks like to me, this looks like a function declaration that doesn't take any parameters and returns a day of year object. This one doesn't look that way, or this one doesn't look that way, right? So we don't do it. I mean, this is not option. If the constructor doesn't take any parameters, then this is the way you are going to declare your objects. You cannot do it this way. Okay? Good. So this is something. By the way, I challenge you, maybe some of you did. This is a very simple class, right? Day of year class. I challenge you after the class to write the exact same class yourself without looking at your book and other code. Okay? Just write this simple day of year class yourself and test it using a main function. I bet many of you will have problems remembering this initialization section. How did it work? Many of you will have problems with implementing these member functions, and many of you will have problems writing these public and private and that kind of stuff. Okay? It is not because these are difficult. It is because these are some details that you need to get used to. If you don't exercise, if you don't write these kind of stuff yourself, it will be very difficult for you to catch up later. Okay? Catch up later. You have to write this kind of example code yourself. So that you get used to the syntax. Otherwise, it gets too much. I mean, there is a detail here. Okay, this is another detail. I mean, this is just another detail. It is natural for you to think that this is okay. When you write it that way, the compiler is going to give you a weird compiler error, and the compiler error will not be at this line, right? The compiler error will be, suppose that you did this, day of year date. The compiler error will be date.output. When you say that, the compiler will tell you that date is a function. How can you call another function on a function, right? This is not an object. This is a function, the compiler will tell you. Okay, so it's going to be a weird compiler error. I am not saying that you are not going to get these. It is better to get these kind of errors and to understand what is going on early, okay? Early. So all the things that I am telling you are details. Many of the things are details. And many of them has to be remembered. The best way to remember is not to read. Of course, reading is good. Reading the book is good. But the best way to learn this stuff is writing it and exercising it. Okay, write this class yourself. And I bet all of you will have these kind of small problems. So how did it work? I don't remember. So it was so simple, but I don't remember it. Because learning a syntax is not that easy. Once you learn it, it stays there as long as you keep practicing. But Learning will take a little bit experimentation. Okay, good. Let me move on then. As we said before, you cannot call constructors. This is wrong. Can also call constructors again is wrong. Once you have an object D, you cannot call day of year on it. Day of year. Okay? You cannot call day of year on an already constructed object. Okay? So the best you can do is this. D gets the value of day of year 5, something like that. Okay? And the book says that convenient method of setting member variables, and this is not true either. Okay, I don't like this or that. The best way to set the values of objects are d.set 7 5. Well, maybe the book says that I didn't write the setter, I am using the constructor for that. And that's not a good way of doing things. Okay, I don't like this because just to be able to set the month and day values of this one, it is creating another object in memory, and I am making an assignment to D, and I'm getting rid of this object. This is so inefficient and unreadable. We don't do it this way. Okay. So the same thing. This one creates an anonymous object with no name, and I make this assignment. Okay, so there is this concept of default constructor. Default constructor. Remember what we did before? Our previous code, can I show you the previous code? Can I open it? Open. What do I open? Oh, okay. Let me open this. The last one. Okay. This is the last example from our chapter number 6. Remember this one, there is month and day here. There is month and day. And I have our input output setters, get month number, get day, etc. Okay. And as you see, there is no constructor defined in this class. But at line 26, I create two objects of the class. Okay. I create two objects of the class. So how are they initialized? Since I did not provide a constructor, they are not initialized. The fact that I did not provide a constructor doesn't mean that there is no constructor actually. If you don't define a constructor, there is a default constructor defined for you. Okay, there is a default constructor defined for you, and it doesn't do anything. Okay, so if you don't define any constructor, the compiler will define and implement a default constructor for you, and that default constructor will take no parameters. Okay, and we will call it no parameter constructor. Okay, so it is auto-generated. So the question is, does compiler produce a auto-generated constructor? Answer is yes and no. Yes, if you do not specify, if you do not declare and implement a constructor, yes, the compiler will do it for you. No, if you provide even a single constructor, the compiler will not generate a constructor for you. Okay, and if you do not provide a constructor with no parameters, okay, then you cannot do this. Let me show you with an example. Let me go to this example again. Let's say I don't have this line. I don't have a constructor with no parameters. in that case, the compiler will give me an error message here. It will say that I cannot make this object, I cannot create this object because there is no constructor to make it. There is no constructor that doesn't take any parameters. There is no parameter constructor. Okay? But if I do this, if I erase all of my constructors, then this is okay because the compiler is going to make a default constructor, and that default constructor doesn't take any parameters. Of course, in that case, these two will not work. Okay? Let me do this then, like, okay. So let's make this date 4. So line 31 will work even if I did not declare and implement any constructors. Line 31 will work because if you don't provide any constructors, okay, the compiler will make a no parameter constructor. That's okay. But if you specify a constructor, let's say I specify 2, in that case, and I did not specify this one, and in that case, this will be a problem. Line 31 will be a problem because you don't have a constructor that doesn't take any parameters. And the default constructor will not be created automatically for you, will not be generated automatically for you. Okay? That's the definition of default constructor. The book kind of use this idea interchangeably. Default constructor is a no parameter constructor, and it is created by the compiler if you don't provide any constructors. Okay, that's the default constructor. Default constructor has to be no parameter constructor, but you may write on your no parameter constructor yourself. Line 14 is not a default constructor. It's a constructor that you have written, you have implemented, but it is no default constructor. Default constructor is the constructor that is produced by the compiler. And by default, the default constructor doesn't do anything, doesn't do any initialization. Okay? Good. I think there is a question. Mohammed is asking me a question. So if you do not create a constructor and use set functions all the time, it is just bad design or have another bad issues? Mohammed, that's a very good question actually. I like these kind of questions. Yeah, it's a bad design. He says that what is wrong with this? Okay. What is wrong with this? I just made 2 objects, today and Bah birthday, and I'm a good programmer. Okay, I'm a grown-up programmer. I know not to do this. I know not to do this because if I do this, I know that there is nothing good can come out of this, right? I know this one, but object-oriented programming says that no, don't trust your users, don't trust your customers. Okay, either knowingly or involuntarily, they will make these kind of mistakes. We don't want to do that. In object-oriented programming, it is always safe to have your objects valid all the time. Keep your objects valid all the time. That's a programming technique, okay? That's how you write your reusable code. Don't let your user go in trouble because he was not careful, because he didn't know, etc. Okay? So the answer to Muhammad's question is, yes, it's a bad design. Yes, it's a bad design. And second part of your question, does there have other bad issues in terms of performances and that kind of stuff? No, but one day later or sooner, you're gonna have problems if you do not initialize your data right. I bet many of you had problems like this: integer I, then without initializing it, Without initializing it, you use it with some kind of a calculation. Okay, you use it with some kind of a calculation, and maybe this. And most of the time this has worked because most of the time I happens to be 0, but sometimes I becomes minus 500 for some reason. Okay, you did not initialize it. That's exactly the same problem. If you do not initialize your data members, one day it will hurt your customer. And hurting you is a good thing because I mean once you get hurt, you would fix it yourself. But if your paying customer gets hurt, then that's money. That's not good. Your boss will get hurt, and when your boss gets hurt, you're out of your job. Okay, good. So, any other question? Before the break, I may take one or two questions. Any questions? Okay, let's take a break of 10 minutes. After that, we will continue our discussion with the constructors. Let's be here at 9:32. Okay, people. So know the difference between default constructor and no parameter constructor. Okay, all the default constructors are no parameter constructors, but there are other no parameter constructors such as the ones that you can write. Okay, and the question that Mohammed is asking is a very good question. Think about that question and think about the answer that I give him. Many times actually, let's talk about this question again. Many times the questions that comes to your mind is about, it is okay to do that, right? Yeah, the compiler will not object to it. Compiler will compile, but in terms of object-oriented programming philosophy, is it okay? Okay. Compiler doesn't know much about the object-oriented programming philosophy. Okay, it knows about the classes, it knows about the public section and private section, but if you make a mistake, if you make a private data public by mistake, compiler will not know that. Okay, compiler will compile it. It is okay for the compiler. Okay, it is okay for the compiler to erase this line. I erase this line. Okay, now all of my data and everything is public, right? And this code will compile, right? No problem. The compiler will not tell me that you are making a big object-oriented philosophy mistake. Doesn't know about it. So most of the time, these kind of things has to be handled by you. You are the object-oriented designer. It is not the compiler. Compiler is just a helper for you. Okay, compiler is just a helper for you. If you are doing the object-oriented programming, you have to know the rules. Okay, Mohammed Ali has a comment. He says 3, and I agree with him. I don't know what it is, but 3 is a good number. Yes. Class type member variables. Remember our code again here. I have 2 integers as data members. Okay, and the question is, can I have other types of data members? Such as let's say string str. Okay, well, that would be a very nice addition actually. Let's the name. Okay, string name. Maybe the name of the day, for example. Well, that doesn't make any sense much, but can I do this? The question is this. Yes, we could. You may have as your data members objects of other classes. Remember, string is another class. The book has a good example on this. Let me show you the example. Am I going too far away in this case? Day of here is here. Yeah. Okay. Yeah. Let me show you this example. Maybe before going to that example, there is another good class. I like to show you this class. It is bank account. Okay. The name of the class is bank account. We are going to represent a bank account. And what would you have in a bank account? You would have your balance and the rate, interest rate. Balance is bakiye. Interest rate is the faiz oranı. Okay. That would be 2 doubles. Okay. Maybe you heard this before. Never use doubles or flows to represent money. Okay. Always use integers to represent money. Integers, and for Turkish liras, integers. For Turkish kuruş, use integers again. So, but this one, for the sake of pedagogic reasons, just use double. Okay. So this is your balance, this is your rate. Or another constructor says that, okay, I'm not going to use doubles. For the dollars part, okay, let's say if you have $5 right? If you have $5, so 5 will be dollars, cents will be cents, and double is rate. So that is going to be interest rate again. And the third one is it is just dollars and rate, no cents part, no parameter constructor. Okay. And there are some functions, update function. What does it do? 1 year of simple interest that has been added to the console. So when you call the update function, it will add the interest to the money, the main money. Input and output is there. This one will return the balance in terms of double. This one will return the balance in terms of integers. So the dollars part. This is the cent parts. This is the rate. It returns the rate, and these are the setters. Set balance in terms of dollars, in terms of double, in terms of integers, etc., and set rate. So these are our getters, 3 getters and 3 setters. That's good. And some of them are mutators, some of them are accessors. Okay, good. So without looking at the private part, let's go to directly the main function. Main function says that I have 2 accounts. One of them is this. Okay, $1,345.52 is the balance of the account, and the interest rate is 2.3%. Okay, and I call output on it. Okay, and I call output on the second one. It looks like the no parameter constructor sets everything to 0, I guess. And then I use this line 64, the line that I don't like, $999.99, and interest rate is 5.5. And it uses input and output on the account 2, okay, and then I update account 2 and I output again. Okay, so as a customer, I will write this code. See, I have never shown you how I implemented all of this stuff. I have never shown you the private part of the class, but as a customer of this class, I am free to use it the way I like because I see the interface. Interface is just this, okay? This is my interface. All the public parts up to the private. What is private? Okay, this is my whole interface. Okay, so that's the nice thing about object-oriented programming. It forces you to design your interface first. Okay, you design your interface. As soon as you design your interface, you may go use your class in some main function, in some driver code. Of course, it will not be linkable, it will not be runnable program, but as a customer, you may test it. Does it work? Can I write this code against this interface, etc.? Okay. After you write your interface and you write some driver code, you may start implementing your stuff again. Okay. Let's go to the implementation. Implementation is here. Let's see what we are doing here. Okay. So this is the one that takes balance and rate. Okay, to be able to do the implementation, I need to show you the private part. Private part is always a very crowded private part. It turns out that it is using integers to represent dollars and cents. Like suggested, what did I say? Do not use floats and doubles to represent money. It is actually underneath the class. It is not using doubles. Okay, it is using integers. Account dollars, account cents, and the rate is a double. That's okay. Okay, and I have 1, 2, 3, 4 functions. It looks like these are all helper functions. They are not public. What they do? Given a money, let's say a double money, let's say $25.50, this one returns 25. this one will return 50. And this is for rounding number. If I have 2.85, it will return, I guess, 3.0. Just 3, sorry, integer. And fraction is what? Fraction converts a percent to a fraction. For example, 50.3 will be returned to 0.503. So these are all implementation dependent. That's why we are having difficulty understanding it without looking at the implementation. But the above part has different from the implementation. It is for us as a customers to use this class, and these are much clearly explained, and they are very usable without knowing the implementation. So let's go to the implementation again. Okay, so remember our private data. Remember our private data. We keep our money as integers, okay, for the dollar part and the cent part, okay, for the dollars part and the cent part. Let me actually try to show you this on a, oh no, it's not there. Okay, so bank account, bank account B1 $100 and 70 cents and 0.5 interest rate, and B2 is 10.2 comma 15.2. okay, so how would these two look in my memory? My memory is something like this. B1 is here. How many data members do I have? I have 3. Dollars part, cents part, and the rate. For B1, dollars part will be 100 integer, 70 integer, and 0.5 is the double. And for, let me make this B2. For B2, okay, 10 is the dollars part, 20 is the cents part, okay, and 15.2 is the interest rate. So this is how it would look in my memory, because I have only 3 data members. Okay. So let's look at this constructor. The constructor, should we start from the simplest one? The simplest one is the simplest constructor is the constructor that doesn't take any parameters. Line 98, simplest one. Okay, I am using the member initializer syntax, initialization section. I set 0 to account dollars. I set 0 to account cents. I set 0.0 to rate. No problem. It's good. Okay, let's move up. Let's look at this one, 92. It is a little bit more complicated, but it's okay. I just set dollars to dollars. Okay, dollars to dollars. Cents is 0 because they did not provide the cent. And rate is set to that. And it looks like I am not doing any checking. Should I check? What would be a bad dollars amount? I don't think that there would be any bad dollars amount, right? Because the balance could be negative or positive or 0. Any integer value would be okay. right? Any integer value will be okay in terms of dollars. So I am not going to check it. Rate again. Rate, the interest rate could be positive or negative. Okay. Sometimes they take money from you with the rate. Okay, so I'm not going to check it. Okay, let's look at this part now. Line 89. I have dollars, cents, and rate. It looks like I am not going to use the member initialization syntax, and I am going to use the setters. Well, maybe, I mean, I did not look this rate stuff yet, but it looks like rate might have some validity check in it. Should we go there and, well, maybe with the set balance, yeah. We are going to look at set rate and set balance. I think there is range checking happening in there. Okay. So this one says that I am not going to use the member initializer syntax. I will use the member function, public member function set balance, and public member function set rate. And the one at the top, the constructor that takes a double, this is a more difficult one. Why? Because my members are in integers, and I am providing a double as a balance. So I am saying that for the account dollars, I get the integer part of the balance, okay, and I get the cents part of the balance. So I am calling to private member functions to get the dollars part and the cents part, and I set them to account dollars and account cents. For the rate again, I am using the set rate. It looks like there is something happening with the set rate. Let's go to set rate and let's go to, can I do this? Okay, set rate, where is set rate, set rate, set rate? Did you guys see set rate? Yeah, here it is. Yeah, okay, so I was wrong. Set rate has to be greater than or equal to 0.0. Set rate has to be greater than 0.0. And as always, if it is not, then I print out a error message and I terminate my program. This is how set rate works. Okay, that's how set rate works. How about set balance? See, these three constructors are using set balance here. Yeah, only one of them is using the set balance. And set balance is a public member function. Let's look at set balance. Okay, here is the set balance. Set balance says that I will get the balance as a double. Okay. By the way, there are two set balance overloads. One of them takes a double, one of them takes an integer. Let's start with the integer one. It says that I will take the dollars and cents as two separate integers, and I am saying that, just read this code, line 168. It looks like it asks me to enter either positive dollar cents or negative dollars and cents. If your balance is positive, if you have money in bank, then your dollars and cents, they both have to be positive. If you owe money to the bank, if your balance is negative, then your dollars and cents has to be both negative. Okay, so that's what it says. If dollars less than 0, cents greater than 0, or dollars greater than 0, cents less than 0, then inconsistent account data, exit. So that's what it does, set balance. Otherwise, I just make these assignments. So your dollars and cents could be both negative or could be both positive. So this is set balance with the integer. How about the double one? Double one says that I will take the balance as a double, and I will call dollars part of the balance and cents part of the balance, and whatever they return, I assign them to account dollars and account cents. Okay, good. So that's how set balance works. Both overloads. Getters, get rate just returns the rate. Get cents returns the cents. Get dollars returns the dollars. Get balance. It is supposed to return a double. So what am I gonna do? I will add account dollars to account cents times 0.01 because this is cents. I need to convert it to dollars. I converted it to dollars now. Okay, I converted it to dollars, and once I convert it to dollars, I can add account dollars, and this makes a double. And this is a double addition. I return a double. Good. Okay, this is get balance. Okay, did I miss anything? Okay, let's go to top. Let's go to top after the constructors update. Remember what update does? Update says that I will add a yearly interest to the main money. So first it converts my balance to a double. Okay. So line 103. Just tell me something better than this line for 103. I didn't like this line. Just replace it with something else. I don't like this line. You might say that it is your problem. No, it's your problem too. If I don't like it, it's your problem too. I am going to replace that line with, tell me something. I don't like this line. I am going to replace it with, how would I get the double balance of the account? And this is the calculation. What are you guys typing? Atakan, what is comma? Muhammad Ali already gave me a 3. And you are giving me a comma? Jacob, get dollars would return you only the dollars part. I mean, why would I use get dollars? Let's go to the interface. Interface. What function can I use from here? How about this one? Yep. Mohamed Oğuz, yes. Get balance. Get balance is the correct version. Correct. Would have been the better alternative. Get balance. Why? Because get balance is already doing that. Okay, see, get balance is already doing this. Account dollars plus account cents times 0.01, right? So it makes more sense to, instead of repeating this, remember, code repetition is bad. Just do this. Okay. So I get the balance. I get the balance. And in that case, I mean, if I fix something in get balance function, this line 103 will be automatically corrected, right? So I add to the balance times fraction rate, and then I assign the dollars part of the new balance to the account dollars and cents part to the account cents. Okay. Good. Or do I have a set function that takes a set balance? Yeah. See this one? Let's use this one. Let's use this one. Where is my, okay, get balance. I calculated the balance and I like to do this and get rid of these two. Okay, this is much better code than what was there before. I get the balance. Okay, and the nice thing is that I am using the public interface of the class like a customer. Always try to use the public interface of the class because that's the strongest part of the class. It has to be right. And your code will not be broken because you are using the public interface. Public interface is the strongest part. I always try to, even if you are a member function of the class, try to use the public member functions. Okay? And we'll talk about this later. So this is update function. That's good. I just use get balance and double and updated the double and I use the set balance. Okay, let's look at this input. Input is balance as double. It's a temporary. It says that enter account balance with a dollar sign. I get a double and I get the dollars part and the cents part of that double. And I get the interest rate and I use the set rate. Okay. Again, instead of doing these two lines, let me not erase them, but just fix them, right? Again, use set balance. And like that. Don't try to write this kind of, because I keep repeating myself all the time. And it is okay for the book because the book is trying to tell me something. I mean, it's trying to show that I can access all of this stuff and etc. But the better code is using the functions already available, reusing them over and over and over again. And this one is for set rate. So it doesn't make sense. Why would you do this calculation yourself here and use set rate here? I mean, you could have done the same thing with the rate too, but he used the set rate function, but not the set balance function. Set balance is good, much better. So input works that way. And the output, I get the, oh, okay, let's look at the output code. Output code is going to print the dollars amount on the screen, in a nice formatted way. It gets both account dollars and account cents as integers, but it takes the absolute value of them because they could be negative, right? If the account dollars is negative, then I put a negative sign at the beginning. Okay. And I print out the dollars part. So it looks like it's going to be something like, if I have 100 minus $100.50, let's say, let's do this. If I have minus $100.05, it's going to be a minus 100. Then there is a dot. Yeah, that I know. If the absolute cents is less than 10, it's going to put a 0, then the number itself. Okay, so it's going to be printed like that. And then after that, it's going to print the rate part as a percentage. So it's going to be account balance. Account balance is dollars, and then rate is, there's end of line, of course, let's say 23.5%. So this is how the output works. Okay, I already talked about get balance, get dollars, get cents, get rate. Okay, these are all good. Set balance, we already talked about that. Set rate, yeah, we talked about it. How about this? Dollars part. What does dollars part do? It takes a double and it just returns the integer part of it. Interesting. So if I have $100.25 as double, it will just return me 100. Okay. And the cents part just does the other way of it. If you have a double amount, you multiply the amount by 100. So there is nothing like as cents. Then so I am converting everything to cents. If I have $100.21, it's going to be 10,025 cents, right? So this is going to be 10,025, and I convert that to positive absolute value, and I round it. I get an integer, and I take the modulo so that I would get the cents part. And if the amount is less than zero, I would return a negative number. Otherwise, I would return the cents itself. So if I have $100.25, this one dollars part will return 100. This one will return 25. That's good. Okay. These two functions are written fine, but I say that they I don't like some stuff with these functions. Let's look at this one. I say that this function does not belong to this class. Why do I say that? I say that this function dollars part or cents part, or for the same reason maybe round and fraction, these 1, 2, 3, 4 functions, they don't look like they are part of this class. Just look at them and tell me why. And by the way, there is a question. Hocam, in dollars part function, can we just return amount instead of static type because return type is already end? It's a C question. Just return amount and it's an integer. Some compilers will not like it. You'll get at least some kind of a warning message. Okay? You will get some kind of a warning message. Okay, you think about this question that I ask you. I don't like these 4 functions and I am back. I have to get this. Sorry. Efendim? İyi günler. Okay, so what do we have here? They don't use any class variables. Okay, Fatih, that's a very good answer. That's a very good answer. But you need to explain it a little bit. Fatih Khan. They don't use any.
So they are like independent from the class.
They don't look like they are part of this class, right? What was the meaning of encapsulation? The encapsulation means that put together all the related data and the functions that work on that data, right? So the related data is this. Okay, related data is these three stuff. The dollars part of the account, cents part of the account, and the rate. And the functions that work on the functions. Do you guys hearing me? Do I sound fine?
Yes, sir.
Well, something happened with my computer. It's that noise sound is gone. Okay. So anyway, I am recording it. That one is recording it. Yeah, no problem. So all the functions, like the constructors, are modifying all the private data, update and input and output, or they are either modifying it, they are either accessing it, mutating it, or returning some stuff. But these functions, dollars part, cents part, round, and fraction, they look like they are global functions. I mean, this dollars part, look at the dollars part. Dollars part. It takes this double and it acts on the double. It doesn't need anything else. It doesn't access any data members. It doesn't use any functions inside the class, right? So this looks like a global. So why don't I make this global? I cannot, because in object-oriented world there are no global functions. We don't like global functions. Okay, so we need some kind of a solution, but unfortunately in chapter number 7 I didn't teach you enough material to keep these kind of functions outside of the class, but also outside of the global world. So for now, just know that I don't like these functions, and you should not like things that I don't like, because I am the instructor here. Okay, you don't like these functions. I don't like these functions. The functions are nice, but the way they placed in the private section is not nice. Okay, maybe I should put it this way: the way that they included these functions in the class is not nice, but as a temporary solution, maybe it's a good idea. Maybe it's a good idea to make them private. Why? Because I am going to move them somewhere else later when I teach you enough stuff. Okay. And for now, they are here, okay, because I am not promising anything to the customer. Customer is not supposed to use them because they are private, right? That's one thing you can always use. If you like to hide something, just put it in the private section, and the customer knows that. Well, customer sees it, but customers should not use it. They know that one. Okay. So this dollars, cents, round, and fraction are my privates, and I use them as helper functions. But these are not real helper functions, actually. These are kind of more like globals, because they need all their information as parameters. They need all those information as parameters. Okay, and I looked at them, and that's it. They are very simplified. You get round. I just add 0.5 to the number, take the floor, and convert it to integer. And percent is just divided by 100. Okay, good. So this is a good example of a class, and as a customer I could do that kind of stuff. Where is my, okay, this is, I like to do this. Okay, let me do this. See, no. Account 1 and account 2, right? I like to do this. account1 dot add account2. So what should this one return? It should return me a new bank account. Okay, bank account, let's say new, no, maybe I should say total account is account1 plus account2. What does this do? What does this do? Line 77. I mean, just tell me in English. I have account1 and account2. It just merges two accounts, right? If in one of the accounts, if I have $100.50, in the second one $50.25, it's going to be $150.75. Okay, so I like this that way. Okay, and then after that maybe total account dot output. Okay, I like to do this. How would I change my interface? Oh, there is a question. Anıl Mert Ulaşan says that, sir, or you like, do you like exit? Well, for exit, I cannot do anything. It is already there. I mean, this is C, right? I need to use some of the functions, global functions. I didn't write exit. It was already there. Well, I mean, as an object-oriented programmer, should I like exit? I mean, I like exit as much as I like main. Can you live without main? No, right? So the answer is I like exit as much as I like main function. Okay, so let's write this add function ourselves. First, before doing any implementation, let's go to the interface and let's add it. Where would I add it? This is a good place. Function add. I did not do the return part yet. What does add take as a parameter? What does add take as a parameter? Bank account objects. Atakan, that's a good comment. Two objects. No, two objects. Just single object. Okay, let's do this then. Add bank account other. Remember this one? We always keep saying other. So what should it return? It should return what?
A bank account.
It should return a bank account. Exactly, bank account. Okay, good. So this is my interface. But what did we say? If we pass objects as call by value, it's going to be expensive. That's why we said that maybe we should pass them as references. But with the references, there is this danger of modifying them. So let's add constant at the beginning. Okay, this is my interface. Okay, so what does it do? Takes another bank account and returns the total of this account with the other account. Okay, so everybody knows it. Good. Let's implement this. Copy here and paste there. It will return a bank account, and of course it is part of this bank account class. Oh, come on. This one? Yeah, I found it. and this one, this one, this one, this one. Yeah. Okay, so how? Okay, let's first start with a temporary bank account, and I am not using any. I am using the default, the no parameter constructor. I don't care the initial values, but I know that the default constructor or the no parameter constructor initializes to 0.0. At the end, I will do this, just return temp. Okay, what's your algorithm? Tell me your algorithm. What is your algorithm to add to bank accounts? Anybody? I could get the
Add their balances.
say that again.
Add their balances.
Just get the double balances and add them together. Is that what you are saying? Okay, good. Okay, double the get balance. Get balance will get me the balance of this object, and other dot get balance. This one will return me. This one will return me the total balance in terms of doubles, right? Then I will say set temp dot set balance D. Okay, simple enough. And I will just return D. That's it. Okay, so if you see, I did not use any private data. Good. I did not use any private functions. Using the publicly available functions, I was okay. So try to always do this. Always try to use the public functions. That will make your job easier. If you try to use private data, for example, I could have used something like, okay, sense part plus other dot sense part. That would give me the sense part of the whole thing, right? So I could have done this. Let's say this is an integer sense temp. This is sense part and the other sense part, and Control C. I can do integer again, dollars dtemp, dollars part and other dollars part, right? Dtemp. So I have ctemp and dtemp, but the problem is if sense parts is greater than 100, then I need to do some stuff like I need to add one to the dollars part and etc. There is an if there has to be an if statement, etc. So things are getting complicated because I am dealing with the internal stuff. I have to be careful. I have to be careful about maybe the negative parts too. I mean, some of them negative parts could give me some trouble too. So I don't like going into this kind of, although I can do that, I don't like going into this kind of dealing with the private data, internal workings of the class, although I have all the rights to do that. I don't want to do that. Instead, I am doing this. Okay. I like to go back to that Atakan's question. Atakan had a comment. He said that this function needs two objects. Okay, I like to go that because that was a good point. Although it is a wrong point, but you are supposed to make that mistake. Atakan, that's a very good mistake. You are on track. Okay, there is a Emirhan question to add sense and handle the case of carrying over. Yeah, I don't want to do that. I don't want to do that. Okay. So somebody is telling me that line 226 is wrong. Yes, exactly. It is temp. I just wrote it the opposite. That's good eye, Enis. Let's go to Atakan's comment. He said that this function should have two objects. It is correct. This function has two objects. One of them is this. The other one is my current object. So let's remember how I call this function. How I call this function, go to the main function. Where is my main? Yeah, here is main. Let me copy this. Okay. Over there so that we can put them together, and so as a comment, I am just doing this. Okay, how did I call this function? Account1 dot add account2. This is the first object, this is the second object. And when I am writing a member function, first object is my object. Okay, first object is my object. Let me do this. When I say my object, I'm doing this. Okay, just see my hands. First object is my object. Okay, and the second object is the other object. Other is here. So Atakan was thinking like he's writing a global function, like writing a C function. When you write a C function, you always think about what kind of parameters do I get. I carry all of my data from outside world, and I write it that way. In fact, let's do this, guys. I am out of time, but tomorrow is a holiday. You have enough time, I know, and you don't have any classes today. Let's write this function as a global function, although I know I should not do that in C++. For the sake of just teaching you how to do this stuff, let's write this function as a global function instead of a member function. Okay, so this is how I would write it. I would first, let's write the same thing in my main. Let's say, okay, bank account, total account 2, and I will call a global function. This global function will take two parameters, right? Line 84 is something that we are familiar with. We used to do this kind of thing all the time in C. A function that takes two nice parameters and adds them together, and it returns a new bank account. And I could, of course, just print it out. Or better yet, I could, of course, do this, right? Come on. I could do this. Add dot output, right? This add function will return me a bank account. I am calling output on it. Okay, so let's write this global function. Okay, global function, of course, it is not part of the class. So it returns a bank account. Its name is add. It will take one account object, account 1, and it will take another bank account object. Account 2. And just tell me what should I do. I think I should do the same thing again. maybe a little bit. Well, yeah, I think I will copy paste and modify it. There is a trick. I mean, there is a much shorter code. Maybe I will write, okay, bank account temporary, and there is no way that now I can use this part, sense parts and double part, because this is a global. There is no way I can access these, right? So get these out. So just tell me, how should I change this line to 50? Just tell me, how should I change this to 50?
Account one dot get balance.
Exactly, account one dot get balance, and instead of
Account
other,
two
now it
dot
is
get
account two. Not the naming. For this one, it is other. Why? Because I myself is an object. I am part of the here. I am part of the class. I myself is an object. Okay. I have my balance, and the other one has a balance. So this line is, this is my balance plus the, okay, other's balance. Let me spell that. Okay. This one doesn't say so. It says I have two objects. The balance of the first object plus the balance of the other object. Okay. Oh, mistake there. Another mistake there. Okay. And I add them together, and I gave me a double D, and I set the balance of the temporary, and I just return the temporary. Okay. So this is how you write the global function. So you might say that I still don't understand the point of object-oriented programming. The function here, the member function, these two functions that I highlighted with green, are doing exactly the same. Why would I say that the first one, 231, is a better way of doing things? They are doing exactly the same thing, same calculations. There are two objects going on, okay? The thing is that you will not notice the advantage of object-oriented programming by looking at these kind of simple functions, okay? Object-oriented programming will force you to encapsulate, will make you think in terms of data, okay? What is your data? Data is dollars and cents and the rate. And what are the functions that is working on those? Okay, those are the add function, set balance, get balance function, and that kind of stuff. It will organize your thoughts. It will organize your design decisions so that you always write related stuff. You don't think about anything other than the class. With the global functions, other things might confuse you. Other things you might say that, why don't I get some information to the add function from somewhere else? Okay, because it's a global function, it can get anything it likes. Okay, so with the object-oriented programming, you always think about your class only. You don't think about the other stuff other than your class. Okay, so those are some of the things that you can notice maybe at this phase, and it will be more and more clearer later. Okay, once you build your class foundations right correctly, writing your functions is going to be easy, and after you are done with your class, it's going to be much more usable, reusable software that you have developed. Okay, good. I think I'm way out of my time. I should stop here, and we will continue on Monday. Any questions? Read chapter 7, 6 and 7, and better yet, memorize the chapter 6 and 7. These are the two most important chapters. And I urge you to write these classes yourself. Okay, write this bank account class yourself without looking at the book, without looking at the code that I gave you. Okay, you will notice that you are missing some stuff, and you don't remember it. You don't remember it right, and that's what will make you learn it. Okay, so Mohammed, yes, Mohammed, your homework is coming. Yeah, it's not going to be your holiday present. Yeah, it's going to be that there is a homework. Okay, The homework is going to be your hex game, and you are gonna represent a cell of the hex game using a class. And this cell will know its neighbors: north, south, southeast, southwest, etc. There are 6 neighbors, right? Okay, have a nice holiday, happy Republic's Day, and happy Kandil's night, and I'll see you on Monday. I miss you guys. I don't know, I mean, are you guys real or you are just chatbots? And if you are a chatbot, you are doing a very good job. Most of you I don't remember. I don't recognize you. I don't remember. I don't know your faces. This is so weird. I promise I am not a robot. I am a real person, as far as I know. I hope this thing is going to be over soon and we will see each other. Okay. See you on Monday.